Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, we're going to take the second rule under our main topic, that is sine cosine rule. What we are going to take next is the cosine rule. So let's begin. After completing the very lesson today, my dear student, you'll be able to state what is cosine rule, and you also be able to use that same cosine rule to solve triangle problems. These are the two things I hope my dear student will be able to do after completing the very lesson today. So as usual in your paper writer segment of the lesson, today I'll give you another special group of numbers, and those group of numbers are called reverse case numbers. I will explain what are reverse case numbers and give you a few examples of them after completing my lesson today. So don't go away. To begin the lesson, my dear student, let me first state what is cosine rule. For me to do that, I will now consider this a typical triangle. This is triangle ABC. If you have triangle ABC, the length opposite to the angle at E is denoted by small letter E, and the length of the side opposite to the angle at B is denoted by small letter B. Likewise, the side opposite to angle at C is denoted by small letter C. So if I am to use this as a typical triangle to state what is cosine rule says if you wanted to find the length, for example, of side BC, which is denoted by small letter E. So what you simply find is the A square according to the cosine rule. It says the square of this very side is now equals to sum of the squares of the two other side minus the 2 times the product of the two other side and the cos of angle at E, and angle at E is now the angle opposite to that very side that you wanted to find. Similarly, if it is this side AC that you wanted to find, which is denoted by small letter b, so according to the cosine rule says find b square, and that b square is now equals to a square plus the c square. A and the c will now be the other two sides, then minus the product of those two other sides and the cosine of the angle at b. And the angle at b is simply the angle opposite to the side that you wanted to find. So if I pause for a minute and ask you to write the formula for finding this length AB, which is denoted by C, that is to write the formula C square. Let me just pause for some seconds. Just write the formula. I believe you now have something like this: C square equals to B square plus D square minus 2BA cos of angle at C. So this is what we now use to find the length of a side using the cosine rule. You can equally rearrange this to find another new formula if you wanted to find the angle, either angle at E or angle at B or angle at C. It's just an arrangement of this that is making the cos of those angles subject of the formula. Rearranging the very first formula, if I wanted to find the angle at E, so I'll now have a formula for cos E, and that formula will now be equals to B square plus C square minus E square all over 2BC. Similarly, if I want to find the angle at B, so I'll now make cos B here subject of the formula. That will give me the formula cos B equals to A square plus C square minus B square all over 2AC. So if I ask you to write the third formula for cos C, let me just pause for some seconds. I believe you'll be able to write it. Do it, please. Try it. I believe this is what you have as the cos of C. That is the formula for cos C will now be B square plus A square minus C square all over 2BA. Let's just move and take conditions where we apply this cosine rule. Is not in every triangle that you can apply cosine rule. Some you cannot, some you can. Let's just see the condition. So the condition for applying cosine rule is says cosine rule can be used in these two cases. Let us see the two cases. Case one is when you wanted to find the length of the side of a triangle. And case two, if you wanted to find the size of an angle inside that triangle. But in each of these cases, there is a condition. If you wanted to find the length of the side, the condition says in your triangle, the length of the two other sides must be given, and those two other sides, the angle between them must also be given. Just like you can see in this triangle. You have this side BC, side BC, which is denoted by small letter a. So this small letter a, the value is known. And the side AC, this denoted by small letter b, is given in the question. And you can see the angle in between these two sides given. This is the condition that you have to find the length of a side in a triangle using the cosine rule. Similarly, if I move to the second case, that is, you wanted to find the size of a particular angle in a triangle using the cosine rule. So the condition for that is, says you must have the length of all the three sides of the triangle. So let me just move and take examples. Example number 1, you asked to find from the figure below the length of the side lettered y. This is the side lettered y, is the side AB. And the condition says for you to find the y, you must have two sides. I have the two sides, and those two sides, the angle between them is also known. You can see it is 110, so I can apply my cosine rule. So solution to this very problem, let me write the formula for cosine rule. Remember, it says c square equals to a square plus b square minus 2ab cos of angle at C. I use letter C, A, and B because here is the angle at C. What I wanted to find is the side opposite to it. So by notation is small letter c. So substituting that small letter c is now letter y. And the A and the B, I replace them by 7 and 9. I'm going to have y square equals to 7 square plus 9 square minus 2 times 7 times 9 cos of angle at C, which is angle 110 degrees. Look at it. So I'll now simplify what is 7 square, what is 9 square, and find also what is cos of 110 using my calculator. So if that is done correctly, 7 square will give you 49. 9 square will give you 81. And the cos of 110 will give you minus 0.3420. So what I'm going to do next is to do this multiplication and the addition. So addition of 49 and 81 gives you 130. And multiplying 2 by 7 by 9 by this negative 0.3420 gives you positive 43.092. And adding these two values correctly gives answer 173.092. And to find y, I'll simply take the square root of that. That is giving me 13.15 centimeters. This is the length of that side AB, which is denoted by small letter y. So let's move and take another example. Example number 2, we asked to find the smallest angle in this triangle. I have the triangle in which all the three sides are given, so I can find any angle. But in this case, they're asking me to find the smallest angle. Then which one is the smallest? Solution to this very problem. The smallest angle, how you identify it? You just look at the side that is smallest in length. So the angle opposite to that smallest side will now be the smallest angle. In this case, my smallest side is 7 cm, and it is opposite to this angle at E. So angle at E is now the smallest angle. So I'll now write my formula for cos A. That formula, remember, says cos of A to be equals to B square plus C square minus A square all over 2BC. So I will now substitute because I have all the three sides A, B, and C. But you have to take a note. Your A is this side 7, that is opposite to the angle at A. Your B is this side 9 cm opposite to the angle at B. And your C is this side 10 opposite to the angle at C. So you now have cos A to be equals to 9 square plus 10 square minus 7 square all over 2 times 9 times 10. So you now find the square of those numbers. If that is done correctly, you now have 81 as 9 square, 100 as 10 square, and 49 as 7 square. And multiplication of 2 by 9 by 10 gives you this 180. So you now add and subtract. That will give answer after division 0.733. This is cos A. So to find A, you now take the cos inverse of 0.7333. If that is done correctly, you now have the angle at E to be equals to 42.83 degrees. This is the angle at E, and which is the smallest angle. With this, I have come to the end of this very lesson, my dear student. I hope with the few examples given, you'll be able to solve the triangle problems using cosine rule. So let me just quickly move and explain what a reverse case numbers. To do that, let's consider a number that has any digits. And we use that number to generate or to form a sequence of numbers. And those sequence of numbers will have first n terms as the digits in that very number. And other terms are simply obtained by adding the last n terms. If we continue generating more terms using this rule, if it so happened that you have the reverse of the original number as a term in the sequence, then that original number is called the reverse case number. Let's just see examples. 12 is a reverse case number, 341 is a reverse case number. So I'm going to take each of this and make use of this rule to show that yes, exactly 12 is a reverse, 341 is also a reverse case. So let's start with the 12. 12, I have 1, 2 as the digits in that number 12. And I'm now writing the sequence, starting with 1 and 2 as the first two terms, because the first two terms will now be those digits in the number. So other terms I will now add in last 2 to get the next. That will give me 3. To get the next term, I'm adding the last 2. That will give me 5. Together the next time I'm adding the last 2, that will give me 8. So what I'm expecting to have as a term, if I write more terms, will be the reverse of 12. Reverse of 12 is, remember, is now going to be 21. That is 2 take first digit and 1 take the second digit. So let me just move. So to get the next term, add the last 2, that will give me answer 13. To get the next term, I'm adding 8 and 13. That will give me answer 21. You can see 21 is a reverse of 12, which means the original number 12 is a reverse case. Let's take the last one, 341. So 341, in writing the sequence, or in trying to form the sequence, I'll now take those digits in the 3-digit number to be my first 3 terms. So I have 3, 4, and 1. So to get the next, I'm adding the last 3. That will give me answer 8. So to get the next, I'm adding the last 3, 4, 1, and 8. That will give me answer 13. So to get the next, I'm adding last 3, 1, 8, and 13. That will give me answer 22. So what I'm expecting to have, if 341 is a reverse case, is the reverse of 341. Reverse of 341 would now be 143. So let me just continue. So to get the next, I'm adding last 3, 8, 13, and 22. That will give result 43. Next will be last 3 added together. That will give me result 78. Next term, to get it, I'm adding last 3. That will give me answer 143. You can see 143 is a reverse of 341, which means the original number 341 is a reverse case. Let me just give you other examples of reverse case numbers for you to practice. Other examples will now be 24, 36, 48, 52, 71, 682. All these are reverse case numbers you can try and see. Thank you for your attention. We'll see more of these amazing things in mathematics in our subsequent lessons.